Hello everyone! In the previous video I introduced our software for GPS spoofing vulnerability testing. I conducted coherent and non-coherent attacks on a receiver in GPS-only mode. Today I will show you how to spoof a multi-constellation GNSS receiver. I will use exactly the same hardware and connection diagram, and we will try to spoof the M8T module from u-blox. Let's get started. Okay guys, let's start with uCenter for the target receiver configuration. Here we see Galileo, GPS and GLONASS signals. But I want to start with GPS plus Galileo configuration. Let's disable GLONASS. Go to Messages, UBX, Config, GNSS and disable GLONASS. Let's apply the settings. Great, now we see only Galileo and GPS signals. And we need the position deviation map. Here it is. Okay, let's run the simulator. I will not explain how to configure the application, you can watch the previous video for that. I will place a link to the video somewhere here. Let's start with an asynchronous attack. And let's set the offset from the spoofer position at 500 meters. Okay, we're ready. Let's go. If you saw our previous video, you know that there will be no effect here, because the fake signal is not synchronized with the authentic one, and we have to block the reception of real signals. Let's increase the power of the spoofer. Please note that the signal-to-noise ratio of real signals decreases for both GPS and Galileo. At the same time, there are powerful signals that are not used in the position calculation. Let's continue. Well, the real signals have been completely jumped, and the receiver has been successfully spoofed. You can see here that the coordinates have shifted. Okay, let's stop the spoofer. The receiver has lost tracking. Let's wait until it finds the true signals. Yes, well, it took about 20 seconds. And now we enable GLONASS and try the same experiment. Let's go to Messages again. UBX, Config, GNSS, and let's enable GLONASS, apply the settings. Okay, great, now the receiver perceives GLONASS signals too. Let's run the spoofer. Okay, now we see that Galileo signals are suppressed, but GLONASS is not, and the receiver shows fix. That's really cool. Let's increase the power. Well, we have reached the maximum available power, but the receiver is still not spoofed. This is a really great performance. Let's wait a while. It doesn't work. The receiver demonstrates excellent resistance to spoofing. Galileo and GPS share the same radio frequency band. As a result, the fake GPS signals block Galileo. The frequency of GLONASS signals is 25 MHz higher. That is why GLONASS was not suppressed in our experiments. So, what can we do? Let's try to use the JAMA. Okay, it's enabled. You can see that the false and real signals are suppressed. Let's wait a little while. Great, the receiver has found fake signals. Yes, and the coordinates have shifted by 500 meters. The receiver is spoofed. Now let's see what happens when I shoot down the JAMA. Okay, it's disabled. The signal-to-noise ratio has slightly increased. As you can see, the JAMA is no longer needed. The receiver does not perceive original GLONASS signals. Now let's reduce the power of the spoofer. We can see many GLONASS satellites, but they are ignored by the receiver. We are also now seeing Galileo signals. Let's shoot down the spoofer. The receiver has lost signals. Yes, and finally found a real one. So, what can we conclude? GPS plus Galileo configuration does not improve resistance to GPS spoofing. GLONASS, on the other hand, significantly increases robustness. Let's have a look at the receiver's response to a coherent attack. Okay, let's go to the time menu, set synchronous mode, upload Almanac and Ephemeris files again, clear offset, and start. We need to wait for synchronization with real GPS signals. It will start in 10 seconds. Okay, it started. Okay, great. We see a really nice picture here. The receiver simultaneously accepts the real Galileo and GLONASS signals, and our fake one. This is because in the first phase of the synchronous attack, the spoofer generates a GPS signal completely identical to the real ones. Let's try to move the coordinates by 500 meters. Let's go west. You see, the receiver started moving. GLONASS signals are no longer used in the calculation. At the same time, the receiver uses one Galileo satellite. So, the receiver only tracks our fake GPS signals, and the other constellations are ignored. And please note that during the synchronous attack, we do not need to generate huge power to block the real signals. This is a biggest advantage of the synchronous attack scenario. Let's return to east. The receiver is moving to the original position. And now we see that one or sometimes two satellites, Galileo satellites, are used in the position calculation. Okay, now we are in the original point, and now you see that Galileo signals and GLONASS signals are accepted and are used in the calculation. Let's see what happens when I disable the spoofer. Yes, great. The receiver switched to the original GPS signals without losing tracking. That is really cool. Today I demonstrated 3 methods of spoofing a multi-constellation GNSS receiver. High power level of fake GPS signals, using GNSS jammer, and coherent scenario. Subscribe to our channel. Next time I will show you how to spoof time.